Blender's simulation zones. So lots to tell you about in this one. Let's make a start. So here we are in our default Blender scene. I just want to do a little bit of tidying up. Let's hide the 3D cursor, hide the light and the camera. But I actually first of all want to set up the camera so I don't have to come back and do it later. Zero out all the values for both the location and rotation. So the values we want are -75 for the Y and 2 for the Z. So it's a 2-meter high person, 75 meters away from the action. Obviously he wants to be looking up, so we'll have 130 on the X rotation. So now we can select our cube and we can start with our simulation. So let's click on the Geometry Nodes tab and let's hit New to set up a new Geometry Nodes flow. I'm just going to do a little bit of tidy up here. So just right click over this, join areas. So we just have these two views here. It'll just make life a little bit easier for the tutorial. And also we might as well just look through our camera like that. So number pad 0 there. So as I say, this is a simulation zones tutorial. So the first thing we're going to do is set up a simulation zone. So throughout this tutorial, I'll be using Shift A to bring up the add menu and S to bring up the search. And then I'll just type the first few letters of the thing that I want. So in this case, it's sim for simulation zone. And it creates this fancy coloured simulation zone like that. Notice that you can just kind of drag the ends and the zone expands. So what we're going to do here is we're going to take the output of the simulation zone into the geometry output of the geometry nodes. We're going to leave this fella disconnected. So the next thing I'm going to do is add a points node. Initially I'm going to pipe it into this geometry input here, and then I'm going to connect those to there. And then what I want to do is add a set position, this one here, bring it into here in the simulation zone and pipe the geometry through it like that. So then let's do a quick test. So I'm going to enter a value of 0.1 for that Z position there on the set position. I'm just going to increase that radius of the points to 2. And let's actually just look at the front view so we can see our point in action. So there's our point sitting at 0. Now, if we come to the first frame and we press play, it runs the simulation. And the simulation just basically drives the point upwards by 0.1 of a meter every single frame. Because basically that's what the simulation does. It takes whatever instruction you give it and it increments that every single frame. But in this case, this is not the effect that we want because we're just dealing with one point and we want lots of points. So what I'm actually going to do is I'm going to disconnect the points from there. Bring him over here, make ourselves a little bit more space. And into here, I'm going to add a join geometry. Just drop it in there. And this obviously allows us to do join geometry. So what I'm going to do is I'm going to pipe the output of the points into the join geometry. And now the points are going to get incremented on every single frame. So we're going to get multiple points. So let's run that simulation again. And hopefully you can see we've now got that effect. Let me just increase that gap a bit more. Let's go for say 0.25. So you can see individual points being incremented like that indefinitely. So obviously we want something a bit more interesting than this straight line of points. We want a kind of random firing off of points. So to do that, we're going to add some random values to this set position. So to create random values, there is a node called random value. I'm going to use that. So we want to affect the X, Y, and Z. So therefore we need to set it to vector. That gives us X, Y, and Z minimum, X, Y, and Z maximum. So we're going to enter the following values. So for the minimum X, it's going to be -1.75. For the minimum Y, it's going to be -0.75. For the minimum Z is going to be +2. For the maximum X, it's going to be 1.75. The maximum Y is going to be 0.75 and the maximum Z is going to be 3. And then all we need to do is pipe the random value into the offset of the set position like that. I hope you can see that connection being made like that. And now if you run the simulation again, You can see we're getting lots of exciting random points firing off indefinitely like that. And that's looking a lot more promising. So the crucial next step is that we need to control the life of all the particles, or all the geometry, I should say, that enters the simulation zone. And we can do that by creating a named attribute. So here we're going to add a stored named attribute. We're going to drop it in there so it connects the geometry through it. We're also going to add a named attribute. In both cases, we're going to call this life down here as well. Make sure you get the spelling exactly right for both of them. It doesn't matter what you call it. You could call it Willy Wonka if you wanted. We'll call it life because it makes a little bit more sense. And then we're going to add a math node. And we're going to pipe the attribute output. So that's the lifetime value. And then we're going to add 1 to it. And then we take that output into the value of the stored name attribute. And what that's going to do is basically calculate the life of anything that's entering the simulation zone. I want to make the important point that that's not the same as the life of the scene. It's literally the life of each individual element. That's a very important distinction. So we can't actually use scene time because that wouldn't actually give us the same effect. So we'll be reusing this named attribute throughout the composition in order to affect different aspects of the scene. So the first thing I'm going to do is I'm going to duplicate it, so Shift D, and I'm going to use it to affect this set position. Because what I actually want is for the set position to only be affecting the first 30 frames of the life of the particles. So I've got my life here, and I'm going to add a math node. And this time I'm going to set it to less than. So I'm going to take the attribute output, so that's the life, into the value. I'm going to set the threshold to be 30, which is the number of frames of life that we're concerned with. And then I'm going to use this selection input into the set position. So that's basically a switch that operates on whatever you feed it. In this case, it's a logical operation. If the life is less than 30, then set the position. So let's pipe that into the selection like that, and let's have a look at what's happening. And I need to zoom out a bit. Let's have a look at it again. You can see that at frame 30, they're all kind of getting stuck like that. And that's exactly what we want, because this is the frame at which they're going to explode into plumes of sparks. So these are now our sort of basic rockets firing off from the ground, but what we actually need to do, as I say, is to have them explode into plumes of sparks when they hit frame 30. So let's make ourselves a little bit of space here, because what we're going to do is, after this set position node, we're going to add an instances on points. And I'm going to drop it into the flow just there, so it connects the set position output into the points and the instances into the simulation output. Then I'm going to add another couple of nodes. So the first is going to be realize instances. Drop that in there. Then I'm going to add another join geometry and drop that in after, just like that. So these instances want to be another set of points. So what I'm going to do is I'm going to select the original points and Shift D to duplicate them and bring them over here. So I'm going to set the count to 400. Nice lot of showering sparks. Now, the one thing I don't want to do is just connect this directly to this instance here, because if I do that, I will literally be getting 400 new points on every single frame. And if you can imagine, that's really going to quickly clog up everything, and we can't be having that. So what we actually need to do is we need to get them to fire off only on frame 30. And we can do that by using our named attribute again. So let's duplicate the named attribute, Shift D. And in this case, we're going to be using a compare node. So compare, and we're going to switch that to equal. Bearing in mind, we only want this to happen on a particular frame. So let's take the life, pipe it into the A input there, and the B value is going to be 30, frame 30. Just going to set that epsilon to 0 just for purism's sake, it doesn't really matter. And so now we can use this function to drive the selection here. So let's do that. Pop that into the selection there, and then we can add our points to the instance input of the instance on points. So the other thing is I need to pipe the set position output, this one here, into that join geometry. So now let's run the simulation again and see what we've got. We're not really seeing anything apart from what we originally saw before, and that is because our points are not being influenced by any kind of positional change. So what we need to do now is add another set position node after this join geometry. So let's do that. Set position. And again, what we need to do is we need to have a random value. So let's bring in another random value. We want it to be vector because we want it to affect the XYZ position. So let's alt drag over those values, set that to -0.5, the minimum. Alt drag over the maximum and set that to +0.5. And now we'll take this random value output into the offset and let's have a look at what happens. And now you can see that's much more firework-like. We're getting these plumes of sparks that begin at frame 30. So now we can make these plumes a little bit more fancy by adding a normalize to this random value. So that's actually a vector math node. Add one of those and we need to switch that to normalize. And let's take the random value output into the vector input, the vector output into the offset, replacing the existing input. And now if we run the simulation, hopefully we can see that we've got plumes that are a lot more circular. I might just reduce the size of these points so we get a better feel for how they're working. There you go, you're getting a better sense of how it works. And if we zoom in on these, you can see we've got some fairly nice sort of rounded plumes. And I think I'm going to leave it at that, but without getting carried away. So the next thing I want to do is actually affect this radius over time, the radius of the points. So they shrink away and as they die. So to do that, we're going to come to the end here after this set position, and we're going to add a set point radius node. Drop that into here, and that allows us to affect the radius. Again, we're going to be using our named attribute. So I'm just going to grab him from over here, Shift D, and bring it next to our set point radius like that. So in this case, what I want to do is I want to map the range. And I'll explain that in a second. So let's add a map range node. Looks like this. And what this does is allows us to map one set of values to an output set of values. So in this case, we're going to take the life, plug it into the value, take the result, plug it into the radius input. So the top two values are going to be the lifetime of the particles over which this shrinking is going to take place. So I think I might go for something like 50. So they start shrinking at frame 50. And let's maybe go for 150 for the point at which they're going to be at 0. So now we need to set up the particle values. So the minimum is actually going to be a positive number. So it's going to be 0.05. So that's going to be the lifetime of the particles until frame 50. And then when we get to frame 150, we want them to be 0. So they've completely disappeared. So let's just run the simulation again and see how that's looking. And you can see now, hopefully, that the particles are actually sort of shrinking over their life. And that's going to be a lot better. So the other thing I want to do is although these particles are shrinking, they're not actually dying, and we're ending up with quite a lot of particles in the scene. So I actually want to be starting to delete some of these particles over their life. So I'm going to come back to the beginning here, to this original points node. And I'm going to add a scene time node. So you'll notice now we're going for scene time rather than lifetime of the particles, because I want to affect this over the lifetime of the scene rather than the particle's life. So I'm going to add another math node, and in this case I'm going to select greater than. I'm going to take the frame output into the value, and I'm going to set this threshold value to 175. And now I'm going to add a delete geometry node. Drop that in after those points, and I'm going to take my math calculation here, the greater than value, and bring it into the selection. And now if you run the simulation, when we get to frame 175, you can see that it stops emitting particles. Hopefully you can see that. Let's zoom out a bit. So there you go. We're just getting the particles disappearing. So what could also be quite interesting at this point is to add some periodicity into the particle bursts. At the moment, they're just kind of firing off continuously at a steady rate, but we could actually get them to fire off in individual bursts. So I'm going to add 2 more maths nodes, add one like that, and then just duplicate it to get a second one. So this first one I'm going to set to multiply, and I'm going to set the second value to 0.3. I'm going to take that same frame output out of the scene time and bring it into the top value there. So we're basically just slowing down that frame count. And so this second one, I'm going to set it to cosine, which is going to provide an oscillating behavior. So then I'm going to take the multiply output into the cosine value. So now what we need to do is we need to find a way of combining this fading off operation, which is provided by that greater than function, with the periodicity function provided by this cosine. So to do that, I'm going to add a Boolean math node, this chap here, and I'm going to drop it into there, and I'm going to add the cosine into the second input. And the default is AND, but what we actually want is OR. And then if we run the simulation, I hope we can see that we're getting periodic bursts of the particles like that, and then we're also getting that fade off at frame 175. So a much more sophisticated result. So now let's come on to the question of shading, because we obviously want these sparks to have some fun colours over their life, not just be one colour. So right at the end here, I'm going to add a set material node, drop that in there. So obviously the scene has a default material, it's called material, so let's just select that from the menu there, and let's come over to the shading tab, and now we can see that material. Let's rename it as sparks, and what we're going to be doing is we're going to be applying a color ramp to the emission. So let's add a color ramp down here, and I'm just going to set up some 3 colors here. I'm going to add an extra node in the middle. These colours are just all going to be random. I don't really care too much. I will trust you to find some really nice colours for them to go cycle through. And then we can pipe that colour output into the emission. So what we actually need to be doing is we need to be leveraging that life value from our geometry nodes. And we can do that by adding an attribute node. So bring that in there. And to call out the attribute we want, we just type its name into the name field like that. So this is pointing all the way back inside the geometry nodes, inside the simulation, and calling up that particle life value. So what we actually need to be able to do is to map the particle life to the 0 to 1 values of this color ramp. So the color on the left has got a value of 0, the color on the right has got a value of 1. And in order to map those values, we can use a map range node, which we're familiar with. We've seen that one before. So let's take the factor out of the attribute and bring that into the map range value. Let's take the map range result and pipe that into the factor of the color ramp. So then all we need to do is set up the from, min and max values. And I think I want my particles to stay the same color until frame 30. And then I want them to have changed to the final colour by, say, frame 65. So now if we pressed render, we wouldn't actually see anything, and that's because points don't get rendered in the default Eevee renderer, and we need to switch to cycles. So let's just set the samples down to something like 16. I think it's going to be more than enough given that we're just rendering some particles. And then parked on somewhere in the middle of our animation, let's hit render and see what we get. So there you go. You can see we've got the particles in all their different states of colour. And those are going to change over life, and that's going to be really nice. So while we're here, you notice that background was this rather unattractive grey. What we can do is we can switch from object to world, and let's just frame everything up. I don't know why it always frames it out of sight. And we can change this background color to full black. And then if we render, we're rendering over a black night sky, which is going to look a whole lot better. In actual fact, what I did was I didn't render everything inside Blender. I rendered them with transparency. I came down here and opened up the Film tab, and I turned on transparent, and then if I hit render, you'll see I'm rendering over the checkerboard. And what I did was I took all of this into Fusion and I composited it over a night sky, added some nice blur, did a bit of color correction, and I added some flashing of the sky. But that's kind of beyond the scope of this tutorial. Now, obviously this has been a pretty mega tutorial and I don't want to overcomplicate things, but I did want to point out that we can actually customize this whole simulation. If we come back over to geometry nodes, what we can do is we can take some of these values and actually publish them. So at the top level, we can affect some different customizable values. So for example, this greater than node here, which was determining the point at which the particles all disappear, we could take that threshold value and we could drag it to this empty slot on the group input like that. And then if we press N for the sidebar view, you'll see that we've got a value called threshold, and we can rename that as decay. And then if we were to come over to the modifier, you'll see that that decay value is actually published up here, and we could adjust that there. So if we wanted that to be 200, we can adjust that there without having to dive into the geometry nodes. Let's do one more. Let's take, for example, this multiply here, which was that kind of periodicity value. We can drag that into the other spare slot there. Each time it makes a new spare slot. That's just called value, but we could call it period. You can see that that now pops in here, and we can adjust that period from the top level of the modifier. So, as I say, a very long tutorial. I hope I haven't bombarded you with too much information. I just wanted to give you an overall view of simulation zones and create quite a fun project in the process. Hope that's been interesting. Thanks very much indeed for watching. See you again soon.